All right, welcome back to lesson 5.3 on primary trig ratios. This is the second video out of two for this lesson. Hopefully, in lesson one or in video one, you went through and you figured out how to use your calculators to calculate out trigonometric values. Well, once we've done that, now we can start using trigonometry to solve problems involving right angled triangles. So using trigonometry to solve for a missing side, in this case, here's what we're going to do. We're going to follow these steps. We're going to name the sides, choose the appropriate ratio, write the angle and the ratio, then we're going to find the decimal, and finally solve for x. So in this question, I've got my triangle here, and I've got my missing side x. And I notice that it is directly opposite my angle of 37 degrees. So x here, this side is my opposite side. Over across from my right angle, that's my hypotenuse. My hypotenuse is always directly across from my right angle. So I know my opposite, I know my hypotenuse. That must mean that this is here is the adjacent. And I'm just going to mark that with ADJ. So x is my opposite, my hypotenuse is 11, and I don't know my adjacent. So in this case, I know I'm trying to find my opposite side. I know my hypotenuse. I should be using sine. So, right before I do that, the missing side x is opposite to 37 degrees. The 11 centimeters is the hypotenuse since it's opposite to 90 degrees. Since I'm looking for my opposite side and I know my hypotenuse, I should use sine because sine equals opposite divided by my hypotenuse. So I'm going to do sine of 37 degrees equals my opposite over my hypotenuse. And I can fill in those values. I don't know my opposite. That's what I'm looking for. I do know my hypotenuse is 11. So sine 37 equals x over 11. Now we're going to follow the same process we followed earlier. We're going to get rid of our fraction here. We're going to do 11 times sine 37 equals x. Now we're going to evaluate sine 37, and that's going to give us a decimal. So 11 times, in brackets, 0.6018. So when we do 37, hit the sign button, should give us 0.6018. And that equals x. So now we just do our multiplication to find out what x is. And in this case, x equals 6.62. So that missing side length, x, is 6.62 units long. So going up here, x equals 6.62. All right. So let's try another question. Using trigonometry to solve for a missing angle. In this case, we're going to look at the angle we want, and we're going to name the sides of the triangle according to the angle position. Then we're going to choose the appropriate ratio. Then we're going to write the angle and the ratio, convert the fraction to a decimal, and then find the angle using the inverse ratio. So this is when we have to use our second function keys for our trig ratios. So in this case, I look at theta, or my unknown angle, and directly opposite it is sine length 35. As well, touching that angle but not our hypotenuse is our adjacent side, and that is 45. So my opposite side is 35, my adjacent side is 45. I'm looking for the angle theta. In this case, I know my opposite, I know my adjacent. I should be using my tangent ratio. Remember, tangent equals opposite over adjacent. So the side opposite theta is 35. The side adjacent to theta is 45. We want to use as much information as we can to solve this. And so since we know the opposite and the adjacent, but not the angle, we're going to use tangent. So we'll now set it up. Tan theta, because we don't know what theta is in this case, equals our opposite side divided by our adjacent side. Our opposite side is 35. Our adjacent side is 45. So we're just going to solve that out first. 35 divided by 45. And we'll get tan theta equals 0.7778. That's rounded off. It's just a repeating 7. Um, at this point now, we're ready to solve for our angle. In order to do that, we must use our inverse trig ratio. So once again, most calculators, it will be 0.7778. And then you're going to hit your second function key and tangent. And when you do that, it should tell you that theta is equal to 37.9 degrees when we round it to one decimal place. So it's approximately 38 degrees. But we'll leave it at 37.9 right now. So now we figured out how to find an angle using trigonometry. Last example is going to be a word problem. The angle of elevation of the top of the building at a distance of 50 meters from its foot on a horizontal plane is found to be 60 degrees. Find the height of the building. Whenever I get a word problem, I always try and set up a diagram. Sometimes we're lucky enough to have diagrams that go along with the question. If not, we're going to try and figure it out. Now, the first thing is it talks about the angle of elevation. And what the angle of elevation is the angle that we would be at if we were on the ground and looking up at the top of the building. So we're looking up at a 60-degree angle. So it looks like this. Our angle of elevation is this one here, angle C, and it's 60 degrees. If we're standing here and we're looking at the top of the building, we're looking at a 60-degree angle. It also tells us that the distance from the building to where we are is 50 meters. So we want to find the height of the building. So we want to find this height here, and I'm going to just mark that with an X. So now we can go through the process we did with any of our other questions where we try and determine what do we need to find and what information do we already know that can help us find this. In this case, what do I want to find? I want to find the height of the building. In order to find the height of the building, I need to look and see that that is opposite my 60-degree angle. So the height of the building is opposite my 60 degrees, and that's what we need to find. I also know that I know the length of my adjacent side. It's 50 meters. So 50 meters from the building to the point where we're standing and have that 60-degree angle. So this is my adjacent side. This is my opposite side. And I know the angle 60 degrees. Well, I should be asking myself, what trig ratio do I need to use in order to find my opposite side? And the answer to that is tangent. We can't use our sign because we don't know the hypotenuse. So we would be looking for our opposite over our hypotenuse. Wouldn't know either of those, so we couldn't solve it using sine. We could use cosine. So we could say cosine of 60 degrees equals my adjacent over my hypotenuse, 50 over my hypotenuse. Then I could solve for my hypotenuse, but then I'd have to use trigonometry again or the Pythagorean theorem to find out the height of the building. The quickest, most direct route here is because I'm looking for opposite and I know my adjacent, is to use tangent. So I'm going to use the tan ratio to solve this one. And I'm just going to write it out. Tan 60 degrees is going to be equal to my opposite side over my adjacent side. So tan 60 equals my unknown opposite side, x, divided by my adjacent side, which is 50 meters. I'm going to use what I did early on in my first video here. I'm going to get rid of my fraction by multiplying both sides by 50. That's going to leave me with 50 times tan 60 equals x. Now I can evaluate what tan 60 is using my calculator. So 60 and then hit the tan key. That'll give us 1.732. Once again, I rounded to 3 decimals. So, and 50 times that number is going to give us the height of the building. Excuse me. It's going to give us x. So our last step is 50 times 1.732. And if I round that to 1 decimal, it's going to give me 86.6. So x is 86.6. Our units of measure is meters. So the building is 86.6 meters tall. I hope you found that interesting and useful. And if you have any questions, as always, feel free to contact me and I'll help you out. If you don't have any questions, you're ready to go on to the quiz on this lesson. Good luck on the quiz. Take care, and we'll talk soon.